Good afternoon, students. Please write your name as your attendance. Okay, good afternoon, Tejas, Durvas, Sujal. I can see the same name coming up again and again. Now, you will have to ask your friends in group that you should attend the lecture live. Okay. So these are the some of the points that we are discussing. First one, that wave was defined as the disturbance. Disturbance in the medium. So medium may be different. So for example, water. So for water medium, the disturbance may be like a small stone, and obviously, uh, the, suppose this is a tank of water, something like this, filled up with water, and when you drop the stone, okay, so as soon as you drop the stone, there will be some waves generated like this, so and so forth. Okay, so this is a disturbance that is being traveled. That is how we define uh, these two. Okay, the waves. Okay. Now, the second part that we have understood is the amplitude. So, if I draw the wave, something like this, suppose, like this. So, this is 0 and this is the maximum, sorry, the wavelength, lambda. The angle will be here 2 pi, 2 pi radian. In radian, it will be 2 pi. In degree, it will be 360. Whereas this will be pi, that is 180 degree. This will be pi by 2. In general, when we consider the standard wave, then we have the maximum displacement because this y-axis, on the y-axis, what we have is from here. So this is the displacement. The displacement of what? Displacement of the particles present here. Let me use another. All the particles, right? There are different particles here on this string. For example, if we talk about the guitar string, okay. So in case of guitar, what happens? This is a string, and when you pluck the string, then it may vibrate something like this. Of course, it will vibrate in different modes depending upon the thickness of the wire and so on and so forth. So depending on frequency, we'll have some wavelength, specific wavelength. So we'll have somewhere the, for example, the crust, and that maximum displacement from its mean position, centered position, will be called as amplitude. Okay? So that is what the maximum is. The phase that we have defined as the angle. So suppose you take any point anywhere on this wave. Suppose if I take this point, okay, and then this distance and this angle will be the phase angle and path. Okay. So for example, if I write the alpha is the angle. Now on this axis we have theta, and sorry, alpha is the phase here. Now, so this phase will be some angle. So it will be either in radian or it will be in degrees. Okay, whatever it may be, doesn't matter. It is one and the same. So that phase is very important. Okay, that angle is very important. And if you talk about the distance of this point on the mean position, remember not this distance going up and then down, no, not this distance. The distance from say zero position on say horizontal axis, that distance will be called as the path. Okay. Now, if we talk about the path and uh, the phase, so what is the relation between path and phase? Okay. So we have the path from say 0 or say position A, then this is position B and this is position C. So AC is the wavelength that we know. So wavelength is lambda, but for one wave we have the phase of 2 pi. So lambda corresponds to 2 pi. Similarly, we can write the relation as x corresponds to alpha. X not equal to, it is corresponds to, that means it has some relation. Okay. In 12th you might have used the delta instead of alpha. That is one and the same. Okay. So taking the ratio of these two, what we get is say x divided by lambda is equal to alpha divided by 2 pi or delta divided by 2 pi. That is what we have done, right? And therefore we can write as x equal to lambda by 2 pi into alpha, or alpha equal to 2 pi by lambda into x. So these are the two important relations that we get. These are very important relations, and we should note down these relations. Okay. Now, any doubt or any question up till now at this moment? Tejas is saying voice is breaking. Voice is breaking. Let me check. Is that okay now? Is that okay? Because the audio is already connected properly. Okay, okay. Still breaking? It is still breaking? Okay. Let me disconnect the audio and again come back. Just wait for a minute. Okay. Is it okay now? Just check whether you can hear properly. Yes, yes. Okay. So let us continue. So we are talking about uh, Since some student were not able to hear properly, let us revise shortly. Okay. So what we have started with, uh, we started with the waves, and this is the actually last lecture for the waves, and we'll go for laser next time. Okay. So waves are not nothing but it is a result of disturbance. Okay. For example, in water, any medium, we can talk about water. You can see the water waves very easily. So we take water. So if you drop a stone here, then we get the water waves. Okay, like this. If you drop the stone, then we get the water waves. Now these water waves or any wave for that matter will have the amplitude, phase, and then we are discussing about phase difference. Okay. So amplitude means it is the maximum displacement of those particles on that string. For example, if you talk about the guitar string, which is a perfect example of one-dimensional wave, all the particles will start dancing up and down, up and down, up and down. Okay. So depending upon the length, depending upon the frequency that you are trying to tune, so it depends on the tension that you get. Sorry, you give. There is a very beautiful experiment in 12th called as sonometer. Okay, I don't know whether you are fortunate enough to use that sonometer. It is similar to the guitar, and you can change the length of the sonometer, and then you can listen to different vibrations. Okay, so that what are the maximum amplitude you are getting, that is called, sorry, maximum displacement, that is called as amplitude. Okay. Now, how about phase? We yesterday talked about the phase in relation with the circular motion, right? So if we, for example, here, I hope this is visible. So if we talk about the phase, then we have the circle here, and on this circle, what we did is no, okay. So on this circle, we yesterday talk about, say this is the angle 0, this is center, and we have the radius vector here, and this radius vector is moving in clockwise direction. So we'll have different angle, say 90 degree here, 180 degree here. Let me write 90, that is pi by 2, 180, that is pi, and 270, that is 3 pi by 2. Okay. This may not be much visible. That's okay. So similarly, from 0 to 90, we have 0 to 90 here, it is increasing in wave, and then decreasing towards 180. So the amplitude is changing. Okay. So here the amplitude is varying. And this portion was just shifted just after this. Okay. So that 180 starts from here and it goes to 360, and we have seen the reason because in case of circular motion it is coming back to the original position, whereas in wave motion it goes forward. So we have to talk about say 181 in the forward direction, not the backward direction. We cannot go backward. We need to go to forward direction. Okay. So as we have defined the wavelength is the distance in the two same phase points which are occurring just after one another. That is what it is called as consecutive, okay? One after the other. So this length of a wave is called as wavelength. Okay. Now this wavelength, length of one wave corresponds to 2 pi. 2 pi is the phase, and therefore lambda corresponds to 2 pi, and therefore we take any point on this wave. So what we get is the distance is say x from the origin or the 0 point, 0 angle, and the angle at this point is say alpha. In 12th you might have taken delta. Okay, it is one and the same. So x corresponds to alpha, and therefore x divided by lambda, the ratio of these two must be equal to the ratio of these two, alpha by 2 pi, and we get the relation. Sorry, x equal to lambda by 2 pi into alpha, or alpha equal to 2 pi by lambda x. Now we go for another experiment to understand what is the phase difference. Okay. So let me go slightly up, and let me draw for the horizontal and vertical axis. So this is horizontal axis, and this is the vertical axis. Okay. Now I draw different waves here. So one wave, which is normal wave that we are talking about, moves like this. Okay. The amplitude appears to be smaller on negative side. Let me try again. Okay. Not quite right, but it's okay. We'll have some different positions here. So this is 90 degree. Okay. So this is pi by 2, and this is pi, and this is 3 pi by 2. It is 270 degree. This is 2 pi. Okay. Now let us consider there is another wave. Now it doesn't start with the 0. It starts somewhere from here, say pi by 2. Okay. Goes up and goes down and up and down. So this is theta. Now what is the difference between these two waves? For example, this is wave number 1, which is shown by white color, wave number 2 shown by green color. So what is the difference? The difference is that this green color is starting from, or it is reaching to 0, or it is reaching to maximum after the first wave, right? So first wave has reached to the maximum, but this wave has reached to 0 only, and then it reaches to maximum. That means the first wave is leading than the second, or second wave is trailing, it is lagging. Okay, so we have two words, lead. So one leads to two, or two lags behind one. Okay, lags behind means, for example, if there are two runners, so this runner starts with this position, and this runner starts with this position, and they follow the same path, whatever we have shown. Okay, so by the time this runner 1 reaches to say pi by 2 position, this runner 2 will reach to the 0 amplitude. Okay, 0 displacement, not amplitude, 0 displacement. Whereas this first runner will reach to the maximum uh, displacement, that is the amplitude. Okay, so that means it is moving much faster than this one. So that's why we are talking about lag behind. Okay, okay. Now let me take the third one. Now it starts with something like this, and it reaches here, and then maximum here, negative maxima, then zero, again maxima, and then zero, somewhere here. Okay. Now think about the wave number three, the yellow one. Now whether this is related to wave one, it is lagging or leading. My question is whether the wave number three, which is yellow color, is leading or lagging with respect to one. See, when we say leading, if a wave is reaching to its maximum before the other wave, whosoever is reaching to maximum first, it is leading, right? Maximum is positive maximum. Remember, in this case, it should be positive maximum. So tell me, we have the three waves, 1, 2, and 3. The one is white, two is green, and three is yellow. Which one is reaching to its maximum at first? सबसे पहले कौन पहुंचता है मैक्सिमम पे? Yes, you can write the answer as 1, 2, or 3. Whatever you feel.